Very good evening, friends. I, Suraj Kumar Singh, Assistant Professor in Electronics and Communication Department. Today I am presenting the sequential logic circuit. Today the topic of discussion is introduction, characteristics table, classification, latch, SR latch, clock SR, D flip-flop, application and the references. Before going to the main topic, that is sequential circuit, just remember that combinational circuit. So combinational logic is basically the output depend only the current input and has no memory. In my present slide, I will put a quote to Honorable President Barack Obama, because this painful situation, always, my dear student, always try to make them useful and utilize this situation, because after that situation we are the part of that. Come out from that situation, we always try to make the participate of this global economy. So in a global economy, we are the most valuable skill. You can sell your the knowledge. A good education is no longer just pathway to opportunity, it is prerequisite. Now come to the main topic, that is of sequential circuit. Now what is the objective of the sequential circuit? Why we go for the sequential circuit? Here the main objective of the sequential circuit is to understand the basic mechanism, and most of the digital signal cannot implement by the combinational circuit, because output signal is not the function of the input signal. So sequential logic is output depend not only the current input but also the past input value. Example, design a counter needs some type of memory to remember for the past input value. Here the sequential circuit, the basic block of the sequential circuit, the circuit that we have learned so far, that is including the first slide, that is combinational circuit. Here input, present input, and producing present output, and that next state, that is called connected with the storage element, information storing circuit, and that storing element presenting present state, and that present state making a feedback with the combinational circuit. Here the sequential logic circuit. The sequential logic circuit, remember the past input and the past circuit. Output from the system are feedback as a new input. The storage element are the circuit that are capable to store a binary information. Stored in a binary information, that is called a memory. Here see the storage element. Storage element here, storage element. That means we store a binary information which comes from the combinational circuit. This comes from the combinational circuit. It is called a memory. Now when you go for the classification, there are two types of classification: synchronous and asynchronous. First one is synchronous sequential circuit. The synchronous sequential circuit, the output changes only at some discrete state of time. This type of circuit achieves synchronization by using timing signal, is called a clock. Here the one important question will arise here: why we use a synchronous sequential circuit? The answer is very simple: to use the synchronous sequential counter and the flip-flop. That's why we use synchronous sequential circuit. What are the limitations? Here the limitation is that we change, that means the clock pulse of the synchronous sequential circuit is connected to the next flip-flop. So that when one flip-flop is affected, definitely the next flip-flop will be affected due to small changes in the clock signal. These are the basic limitation of the synchronous sequential circuit. An asynchronous sequential circuit, the output can change at any time, that is clockless. So what are the limitation of that asynchronous sequential circuit, my dear friends? The limitation of asynchronous sequential circuit is it is difficult to design. Again I will repeat, asynchronous sequential circuit, the limitation of asynchronous sequential circuit, it is difficult to design. Now this is the complete block of the synchronous sequential circuit flip-flop as a state memory. Here the flip-flop is connected with the combinational circuit and apply a clock pulse. Here the flip-flop receive their inputs from the combinational circuit. This is the present output, and then also from the clock signal with pulses that occur a fixed interval of time as shown is the timing diagram. This is fixed interval of time. This is the synchronous sequential circuit. These are the general graphical symbol of the latches, SR, and this symbol of for negative triggering, that is for bubble. Here we use D latch, that is D for delay, D flip flop symbol. These are the symbol basic. Now these are the SR latch. What is latch? Because I will define the latch, that is defined in my next slide, but also I will explain. Latch is basically, it check all the inputs and the correspondingly it changes the output when enabled. Again I will repeat, latch is basically, it check all the inputs value and correspondingly it changes the output when enabled. For example, SR latch, here we let us understand case by case. When we S stand here, see, when you see this complete circuit, we consider two NAND gate. These two NAND gate are cross coupled to each other. S stand for set, R stand for reset, Q and the Q bar, that is complement. Here these are the truth table of NAND gate. When you apply 0 0, it becomes 1 0 1 1 1 0 1 1 1 0, because the output of NAND gate is XY complement. XY complement. So for the first case, when you consider a 0 1, here the one thing is that added in this before explaining the circuit. The whole 2 point, always remember, the whole circuit, when the circuit is set, when Q is equal to 1, when the whole circuit is reset, Q is equal to 0, and the second condition, always complement to each other, that is Q and Q bar, Q and Q bar. That means we always remember the 2 points. First point is the whole circuit is set when Q is equal to 1, and the whole circuit is reset when Q is equal to 0, and always follow these Q and Q bar complement of each other. So first case, when it becomes 0 and 1, that is I will consider 0 and 1. So then what is the value of my Q and Q bar? Let's understand. Here see the truth table. Whatever the input, either one input is low, the output become is either 0 1 or 1 0. Output is always high, that is 1. So what is the value of Q? That is 1. So I will consider 1. So these 1 is comes to the second NAND gate, that is 1 1, and what is output? 1 1 is become 0, so Q bar is 0, and these 0 goes to the first NAND gate, and it become 1. So 0 0 it become 1. So this condition is called set condition. This is the case number 1. Second case, this is very important. Generally the student are making confusion. What is the condition for 1 1? Generally this condition is called memory condition. Here, because sequential circuit always consider a memory element. In 1 1, what is the value of Q and Q bar? When you see the previous state, 1 is always stored, that is Q is 1. So we here Q is 1. When you see this previous stage 0 1, Q is always 1, and that store element comes to that is 1 1 1 1. So Q become 1. That 1 comes to that second NAND gate, that is 1 1 is become 0. Here output is 0. That 0 goes to the first NAND gate, that is 1 0 is 1 1. So this condition is called 1. So this condition is called a memory element, because we obtain output is 1. This is called a memory element, or this is called hold condition. It is also called a hold condition. Third case, that is 1 0 1 0. Then what is the value of Q and Q bar? So that means 1 0. Whatever the value of 1 0, output is always 1. Output is always 1. So here for reset, I will consider Q bar is equal to 1. So 1 1 it become 0. This is called a reset condition. This is called a reset condition. This is called a reset condition. Next is 1 1. Similarly 0 0. So what is whatever the 0 input is 0 0, output always high. So Q is 1 1 0, it become 1. Q bar is 1, and 1 1 it become 1. So this is not defined, because we cannot store. This is called disallowed case. Now this is the clock SR latch, is sensitive. For when clock is 0, it is no change. When clock is always 1, so when S is 0 0, there is no change. 0 1 is become a reset condition. 1 0 it is set condition. For 1 1 it is undefined. So D stand for delay, delatch. One way to eliminate the undesirable intermediate state in the RS flip-flop to ensure the input S and R are never 1 simultaneously. This is done in the D latch. This is done in D latch. This is the symbol graph. That is the circuit diagram of D flip-flop by using clocked SR flip-flop. Clocked SR flip-flop. This when D is connected input clock signal. That is a NOT gate. Here this is D. That is D bar. There S bar and R bar. So here when clock is high, always high, so 0 in the next state is become 0. Here see the condition when C 0, when you apply a 0, D is equal to 0, a clock is always high, so when it is 0 it become 1. So 0 0 1 0 1, what is the output of NAND gate? 0 1 it become 1. Here 1 1 1 it becomes 0. 1 1 0, again same condition, 0 1 1 1 0. So there is 0 condition, that is reset condition, and Q is equal to 1 set condition. These are the D latch. These are the basic building block of transmission. That is TG board, that is gate number 1, TG2 is gate 2. So when clock is equal to 1, TG1 is closed, TG1 is closed. When it is closed, that means D, closed means short circuit. D is always inverted, that is Q bar. Q is equal to D, Q equal to D, and Q bar is equal to D bar. Q bar is equal to, because we get the complement of here now, we get in the complement, that is when you apply 0 it's 1, when you apply 1 it becomes 0. So when C is 0, TG1 is open, TG open, and TG2 is closed. TG2 is closed, that means this condition is called hold condition, Q and Q bar. Now come to the flip flop and the latches. And the basically, again I will be repeat the definition of latch. Latch is it check all the inputs and correspondingly it changes output. These are called latch. This example SR latch. This cause a synchronization problem, and how to remove the synchronization problem by using latch to create a flip flop that can be respond update only on a specific time instead of any time. Types RS flip flop and D flip flop. Here one important question generally in the ask, that is what is the basic difference between latch and the flip flop. The one of the major difference between latch and the flip flop, latch is labeled triggered and the flip flop is age triggered. Again I will repeat, the basic difference between latch and the flip flop is latch is labeled triggered and the flip flop is age triggered. Next, the characteristics table. What do you mean by characteristics table? So characteristics table is define the logical property of a flip-flop, such as truth table does for the logic gates, and that Qt is the present state at time t, Qt plus 1 is the next time state, that is t plus 1. So this is the basically characteristic for SR flip-flop. This is the present state, and the next state when it becomes 0 0, that is called hold condition, and when it becomes 0, this is called reset, and 1 0 it becomes set, 1 1 is called undefined. These are the characteristics table. Next, these are the characteristic table of D flip flop. When it becomes apply 0, next state becomes 0, this is called set, and become 1, it is called reset. And this is the characteristic equation of D, that is always Q plus next state. The sequential circuit analysis. So basic analysis consists of obtaining the suitable description and demonstrate the time sequence of the input and the output state. Like logic, when you consider the logic diagram, Boolean gates, flip flops of any kinds, ISR, JK, D or T, and the appropriate interconnection. And then third point, that is regarding this sequential circuit analysis, the logic diagram derived from this following, that is Boolean equation, flip flop input, state table and state diagram. Next, the state table characteristics. What do you mean by a state table? A multiple variable table with the following 4 sections, that is what is that my 4 section: present state, input, next state and the output. So present state, the value of state variable each allow state, the input combination allow, the next state The next state, that means t plus 1 based on the present state and the input, and the output, the value of output function of the present state and some time and the input. From the viewpoint, the truth table, the inputs are are inputs, present state, and the output are output, that is called the next stage. For example, a state table have filled by using the next state and the output equation. Suppose at plus 1 is equal to atxt plus btxt. Here is performing OR operation here, and bt plus 1, that is a complement of nxt, and yt is equal to x complement bt plus at. Here this is the present state, that is at and bt, and the input, what is the input? xt, this is my input. Next state, that is called at plus 1 and bt plus 1, and then output. So when you apply 0 0, the input is 0, so t plus 1 0 0, so 0 plus 1 0 0, output is 0 0 0 1, next is 0 1, again 0 1 0 0 0 1. Now state diagram, and vice versa. State diagram, the sequential circuit, the function can be represented in a graphical form as a state diagram with the following component: a circle with the state name in it for each state, a directed arc from the present state to the next state for each state transition, a label on each directed arc with the input values which causes the state transition, and a label on each circle with the output value produced, or in each direct arc with the output value produced. See the example of state diagram. Here when it becomes 0 0, x is 0, y is 0. When you go from 1 to 0, that is x is 0, y is 1. From 1 0, x is 1, y is 0. Similarly, when you go from 1 1, it is 1 1. So it becomes from 1, a is changes from 1 to 0, or from a is changes from 0 to 0 and 1 to 0. So x is 1, y is 0. These are the state diagram. The summary, that is in an application sequential circuit, is timing analysis, the flip-flop transmission gates based on flip-flop design, setup time. In my next video lecture, I have used how to design JK flip-flop, and we will also see the characteristics table, truth table, and then state diagram also. Thank you, my dear friends.